Quirk, the man, the myth, the legend. Welcome to the QTS Experience.
Thanks so much for having me. I'm a long-time listener, first-time caller here.
Well, what's hilarious is when we were coordinating this conversation, I was like, okay, and here's the logistics, and you want to do this remote. How do you want to do it? And you're like, I live like 20 minutes up the street.
I'm your neighbor, man.
You have told me that several times. I keep forgetting. I will never forget again, but you're literally just a few minutes away.
Indeed. Yes. I'm a local for about 11 years now.
Where are you from originally?
Northeast Ohio.
Really?
Akron, Canton, and then Cleveland area.
Yeah.
And worked over in Jersey for a while, and then back to Ohio, and then down to here, following family.
Typical, data center kind of path. People kind of just bouncing around.
You're following jobs or family, right?
Yeah,
it's like
that's it exactly.
That's the migration path.
What I'm very pleasantly surprised about, I've got to hear you speak many, many times. Usually you agree, sometimes disagree. I love your facial expressions. So the cat's going to be out of the bag. I've said this to you before. I don't know if I pay more attention to what's said at the places you speak or your facial expressions. When you can literally see across your face like, okay, I want to be invited back. I'm not sure what they just said. Pretty sure that's the most ridiculous thing I've ever heard said on this topic. But I don't know if I want to play poker with you because you would giggle every time you got good cards or not, but I've seen that on your face.
You're never going to know.
Yeah, I'm never going to know.
I try not to wear my heart on my sleeve, though.
You're wearing it. Small business CEO, why don't you tell us a little bit about what you do now in the industry?
Yeah, sure. I classify myself as a serial entrepreneur because it's more than one business these days.
Okay.
But my primary role is I get up and manage a company of coming up on 500 people.
Wow.
Professional engineering, commissioning, energy management. Just think all the services end-to-end to support the data center industry. Our claim to fame is we wrote the book on data centers, literally, figuratively. Still to this day, very heavily published on an annual basis. I think bi-monthly in the ASHRAE Journal still. Wrote the recent tech bulletin for liquid cooling in data centers that got published through 9.9. Leading a research project, all that fun stuff. Just trying to pave the way, tell everybody else, hey, here's how we get this stuff done.
For people who might be listening, so many people that are at least joining our organization they might be experts at being an electrician or a plumber or an accountant, but they don't know data centers at all. So what's ASHRAE?
American Society of Heating, Refrigeration, and Air Conditioning Engineers.
Okay.
So it's where all us mechanical engineers that went into the HVAC space go to have fun and maybe a few drinks. It's kind of our geek club, right? Like our chess club.
Right.
It's also an organization that is ANSI approved to write standards that get adopted into codes. So they are part of the regulatory path in the industry.
Right.
And therefore, it matters. That's kind of the foundation for a lot of the publications that drive data centers today. So ASHRAE TC 9.9, the technical committee on data centers, which I've chaired before. They're the ones that wrote all the books on data centers. They're the ones that created the thermal guidelines, which define the cooling classes, and the liquid cooling book. And then subsequently, they're the group that created the standard 90.4 for the energy standard of data centers, which again, guilty as charged. Wrote the original title, purpose, and scope, helped stand that committee up and get that out of the blocks in the early days there, kind of to break apart from 90.1.
Why'd you were you asked to do that? Did you see a need to do that? Were you have insomnia?
I think like you, it's a combination of all the above.
Okay.
I get persuaded into a lot of things in life, whether I want to do them or not, and I just kind of fall down that rabbit hole, and the rest is history.
Yeah. How long have you? I see by your ring you're married. How long have you been married?
Oh, north of 25 years, just like being in the industry, north of 25 years. See, after 25 years, you stop counting.
Yeah.
and you just say, hey, man, over 25 years on all things.
Yeah. Well, when you said, I get persuaded into, I'm like, that sounds like a man who's been married for a minute. Yeah, I completely agree.
I have 2 kids that are also north of 25 years at this point. So it's like, yeah, it's all north of 25 years.
We have more in common than just our names than I thought. Look at that.
And we're neighbors.
And we're neighbors. We're going to talk about a number of things, but one of the things that I've been kind of coming back to and thinking a lot about now is the idea of liquid cooling. We've got some future guests coming up. We've had some other guests. Why is liquid cooling such a conversational topic now? We talk about artificial intelligence in data centers. We talk about modernity in data centers and how it serves up modern life in every way. I've been in data centers specifically for over 20 years. I've been in IT for going on 30 years. It was always air cooled. And so new people listening to to our industry, listening to the conversation, for some of them, all they will know is this conversation. But for a lot of us, it's not like liquid cooling's new. There have been these little, in research departments or some other things, they will have these very specialized, but it wasn't the norm. Now, everybody is talking about it.
Yeah.
Why? And is my premise accurate or is it inaccurate?
It's definitely accurate. So setting the stage to clear the air on what is liquid cooling. Okay. So we've been using chill water plants for a long time in the industry. IBM mainframes were doing quote unquote liquid cooling way long time ago, probably even before I was born, as I recall. So liquid cooling, us in the industry, we like to oversimplify everything because we have so many acronyms and so much stuff to keep track of. I'm going to cover also water use while we're at it because that's another really big misconception in the industry. So we could be using water for the entirety of the cooling, meaning we're using it all the way from the rack out to the heat rejection outside, a chiller or a tower or what have you. We're not actually using it in a closed system. We're only using it if we are evaporating it outside, meaning we have this constant inflow that we need from the meter or from the city to fill the system that we're then evaporating. So there's the one misconception in the industry. Most data centers today don't actually use or waste water, aka they're not using it for an evaporative form of heat rejection outside the building. But when we get on that closed loop, so we have 2 different parts. We have what we call the facility water system, or the FWS loop, and that's just, think your traditional chill water system and your chill water loop. And in between there, we've got a heat exchanger that then puts it into this different loop that's got a special mix of water, we'll call it. And ASHRAE termed that as the TCS, or the technical cooling system. And we have a concept that we'll dive into deeper called the S class and the W class that go along with each of those, defines the temperatures. But basically, liquid cooling is, we're talking about the liquid that's used in that part that goes to the server. And that's the quote unquote liquid cooling that everybody refers to when they use that term. S class, just think server is the S. So we're feeding the servers with liquid. Well, why do we need to feed servers with liquid now? Liquid cooling is again, we oversimplify it to our own detriment. Liquid cooled servers still require air. I know, the genie's out of the box now. Like, sorry everyone, you still got to do air cooling.
Right.
Well, so to oversimplify it, let's say this is our GPU chip right here in my hand. Yeah. We just need to get liquid to this thing to help with the heat transfer because it's so incredibly hot that if it didn't have that heat exchanger on there, it'd just burn up in a second. So we have way more heat to remove now. And why did that happen? Where did it come about? We were doing air cooling with CPUs, central processing units, and then we came up with GPUs, and GPUs is graphical processing. And those GPUs just tend to be a lot hotter. There's a lot more getting compressed on that chip and rejecting way more heat to where we can no longer do it with the air. So now we have to do it with a liquid that has a higher heat transfer rate. So whether it's water or it's 25 polypropylene glycol mix with water, or it's some type of refrigerant. It could be single phase or two phase, or it could be an immersion fluid. Right now, where everybody's putting this stuff completely dunked in a bathtub. The immersion is totally different than when we're talking liquid cooling, just to further confuse the world on the topic.
Right.
So when we talk immersion, we're not talking liquid cooling, which is strange, I know, right?
Really?
But, yeah.
I've never heard that.
Well, because nowadays, if you say liquid cooling, everybody thinks liquid to the chip, right?
Right.
And if you say immersion, well, the people are just they'll say immersion. We're talking immersion cooling, so they don't intermix those anymore for that reason. At least not in any conversations I've been at lately, drunk or otherwise. So, yeah, that's really the quick primer on liquid cooling versus just chill water plants, and when we're using water or not using water. Again, most sites these days are not using water. They're not evaporating it into the atmosphere. We're using air-cooled chillers outside, and we're using some combination of air and liquid cooling inside. So every server that does liquid cooling that's not immersion-based also has some air cooling. So just think of everything else on the motherboard where we can't put a cold plate or a little mini heat exchanger on top of the chip. That's really all they are. Again, we like to oversimplify so we confuse the world. Where we don't have that, we still have air cooling inside the data hall that we have to manage on the rest of the chip. Power supplies and the RAM, DRAM, and all the other peripherals that are on there still require liquid or air cooling, I mean.
Right. In my world anyway, I can't think of a data center that we've built in the last 5 years, certainly none that are under construction now, that are probably not liquid cooling first. That's probably definitely their height. Like we're trying to be a hybrid design where we can either do all air or some combination of air and liquid, depending upon. There are nuances to that. I don't want to make it complicated. But we have a pretty good portfolio of what we would call legacy data centers. When we build these buildings, I converted a Sears building, what we would call a brownfield building, that's a 200-year building. We do not want to knock that building down. It's 1 million square feet, and we've converted chip fabs and old newspaper plants or whatever that are incredibly robust buildings. Are buildings like that, whether they're mine or other people, candidates to move from only air to some combination of air and liquid, or is it just too hard and they'll serve up cloud or traditional enterprise or something else? Do you ever get involved in those discussions?
Oh, sure. We're a consultant, right? So this is all we do is figure out those problems.
Okay.
Yeah, I think in general, data centers, in their most simplistic form, are a box that's designed to take many different evolutions of hardware. So if you think of the life cycles of software versus hardware versus the infrastructure, this is the challenge in general that we have as consultants designing these facilities for the industry is you're trying to design a facility that has a capital structure wrapped around it that's north of 10 years, typically up to 20. It's got to be depreciated out over, et cetera, et cetera. There's got to be a rate of return in order for capital to even get on the table. And the hardware and the software within it are changing at an order of magnitude faster frequency.
Right.
So you always have to go in knowing that somehow, some way, that building is going to have to adapt to some future changes on those. And I think the real paradigm shift here recently is when it was just air cooling, when we had things like virtualization that came along, it's a one-time step function in the software change that really gave us a higher density, higher utilizations in the rack. And suddenly we all had to get serious about air cooling, and we couldn't just blow on the racks anymore. Right. And we had to bring in things like CFD or computational fluid dynamics and start modeling and studying this more carefully. But now with GPUs in the fold and AI software applications, the hardware has made this fundamental change, and we have to bring liquid literally to the rack. And again, we did this on we'll call it science experiment basis in high performance compute applications and laboratories and the like with mainframes, IBM mainframes going back a long time, but we never did it at the scale that we're talking now. And, these facilities are already a mess of stuff inside of them between cable tray and everything else. And so now it's like, oh, wait, you want to put pipes in there? Oh, wait, you want to put those pipes over top of the rack? And you want to fill them with water? Are you nuts?
Right.
Yeah. And it's like, no, we're serious. This is what you got to do.
Right.
And it's fascinating to watch over the last couple of years how the entire market went from, you will never put water in my data hall, to now everybody's like, oh, yeah, that's normal, man. And not only are we putting it in the data hall, we're taking it right to every one of the racks.
Yeah.
And everybody's like okay with that all of a sudden.
I remember, I don't want to interrupt your stream of consciousness too
Sure.
much, but it wasn't that long ago. You could not put any mechanical infrastructure on the roof.
Yes.
Or perforate it. Certainly, whatever it was really, really light. It wouldn't be over the IT load, which we're talking about now.
Oh, we blew way past that, man.
And now it's, you
throw
would have
parties on the
multi-stories,
roof.
and now there's samba dancing up there. But it's, you couldn't, I'll just go down a rabbit hole of, you couldn't be near a flight path or these other things, and that's just not.
The rules have gone out the window with AI, certainly in many respects, and I think one part it's a necessity of the technology. You can't do the cooling of these GPUs without bringing liquid into the fold. Right. And the easiest form of that we've already figured out how to do reliably and consistently is with water.
Yeah.
I'm certain we're going to get there here shortly with different forms of refrigerant, but they bring other baggage along with them. So you're always going to have trade-offs. But to your point on geographic location and placement, same kind of things happening. AI software is changing the fabric of all the applications that we run out there, right? It's changing the pace of innovation and how quickly we refresh them, but it's also changing the way in which that software can help with the resiliency of the applications across sites. So I know it's long since touted, many companies tried making their software geo-redundant, and it was really hard to manage because we were brute forcing it with, the man in the middle, as it were. And I think what the industry's finding now is that with AI in the mix, we can level up that level of resiliency on the software to where we can put less emphasis on the physical infrastructure. The other part is, we're just at scale now. I mean, look at how many data centers are in the U.S. Last stat I saw was something like over 5,500 in the U.S. alone. Granted, we're the largest data center market in the world.
What was it? What were you comparing that to?
Oh,
let's just take a 5-year sample, do you think?
Go back 10 years, I think we were less than half that.
Okay.
Don't quote me on that stat, but it was something ridiculous like that. And so you get so many more of them, and you're distributing the applications far more. Then anytime you get an outage, it's not like you're losing all your customers or you're losing the application for the whole world. So a lot of that's come into play to where our sensitivity to placement of these things, to putting stuff on the roof and all that, we're getting desensitized by the capabilities of both the software and just the proliferation of so many of them in the world. It's like there's data centers all amongst us now. They're all around. That's your neighbor's house. Yeah. It's a data center, man, in the basement.
It reminds me of a Roku. I remember coming home. I'd had my appendix out. I came home, and we had this thing on top of our TV, and it had a little knob on it, and you could go from 1 to 36, and it was cable TV. Yeah. I remember how much trouble I got because I had no, it's like
you mess with the bunny ears.
We didn't have bunny ears. We had the big antenna.
It's going way back.
We had the big. We're old, man. We're old men. No, I didn't. My uncles have the story of they were the remote control. They would go up and do the thing. I guess I still did that as well. I'm the oldest of 5 kids. But we were fortunate that we had a motorized antenna. So you would turn it to position 3 and it would get whatever the UHF or the VH stuff.
High-end stuff.
Yeah, high-end stuff. My dad worked for NASA, worked for IBM, but at NASA. But I came home and they had this box. And so I discovered both the joys and the pain of it, all new technology. My dad had warned me, look, we get this guide, but you're not allowed to look at cable TV after 9 o'clock at night without adult supervision. I had no idea what he was talking about. I was 14 years old or whatever I was, 16 years old. And I remember turning it on to it might have been HBO, one of the channels, and it was like Anne Margaret and it wasn't even like we wouldn't even consider it adult content now, but in 1982 or whatever this was, that was pretty risque. I think I was grounded for like 2 years or something from that. But why it reminds me of Roku is back in those days, like we had 36 channels. Now on my Roku, I have 200 streaming channels.
Yeah.
Each of those has dozens and dozens and dozens of channels. You want to watch the Southeast Asian Middle School Badminton Championship, it's in there.
Yeah.
Or Isle of Man TT or everything in between. And so
it's a big world.
It's a big world. But before we'd have our little guide, TV guide that was mailed to the house to find the thing. And now I just set the programmer up. And so to your point, where there's this proliferation of data center and then the systems within the data centers, I guess, they're not, it's not that they're not worried about availability zones because this really depends on the job they're trying to do.
Yes.
But they're not trying to build, I don't have 2 environments usually in a data center that they both have to be up. I've got 4 environments in a geographic region that are in physically dispersed assets.
Yes. Yeah. I think that's more the norm that you have nowadays.
Yeah.
So the risk has been distributed.
Yeah.
And it's changing the way we think about how to build the infrastructure as a result.
Well, help me think about this. So when you were talking about the innovation with air, when I first started doing IT racks, we were about 100 watts a square foot ish.
Yeah.
That's, I don't know if that was the design, but that was the norm. Yeah. We eventually got probably even as recent as 2020, 2019, 300 watts a square foot because we had the big blade servers come in. We had other infrastructure, cloud, was going to do all of these other things. Yeah. But really, most people, even if they got 10 kW worth of capacity, 15 with containment in a rack, they wouldn't use that much. They would use 25 to 30% of it.
Utilizations were way lower.
Right. Yeah. And now everybody, not just this, for sure the more sophisticated, what we would call hyperscale, so those big 10 or 15 organizations in the world, are really getting good at their platforms at maximizing them. Yeah. But even the enterprise, so that next Fortune 1000 or 2000, FinTech, others, are really working on how do I get the maximum value, whatever it is. Yeah. So we went through that evolution, but we were able to solve it even with 15 or 20-year-old technology. Yeah. So I guess my question when we're talking about liquid cooling, sometimes I wonder, kind of like a hammer sees everything as a nail, when we're going to solve these problems, do we see everything as a GPU that requires, whether it's liquid cooling, cold plate, or non-liquid, liquid immersion, do we see everything as a GPU that must be liquefied in some form, or is that, to our detriment? We're going to overbuild or overdesign when that's not the case.
Yes and yes, absolutely. Okay, so does anybody even measure watt per square foot anymore? Is that a metric? Is that a thing? I know, just in the last couple of years, right? But now we talk about kilowatt per rack, and even more recently, megawatt racks, right? Like 1 megawatt in a rack.
Which is ridiculous, isn't it?
It's very ridiculous. So I like to ground everybody on some of the math. So 10 kilowatt rack is like a fireplace in a residential home, except it's not sitting in front of that fireplace. It's putting your head in the chimney, right? So think of that heat load. That's 10 kilowatts. So when we talk about 100 kilowatt racks, we're talking about 10 of those puppies in one rack. And you certainly wouldn't put your head in one chimney, let alone 10.
Right.
And we have to remove all that heat from that thing real quick,
right?
Because it's constantly pumping out that much energy, and hence has to have that much power going in. So yeah, if we go back to the beginning, right? We had CMOS transistors, then we went to bipolar, developed the CPU off that platform. The CPU, there was a great video probably dating back, it's going back a ways, I'm going to say around 2009, where Jensen from NVIDIA talked about the difference between a CPU and a GPU. and its purpose in life. You know, the CPU was really built around the capabilities of Word and Excel.
Yeah.
You know,
Spreadsheet.
a typewriter and a calculator.
Yeah.
This is purpose in life, and the way it does computations. And then you enter the world of GPU, and it's doing graphics, it's doing pictures and video.
Ray tracing and
Yeah, and all the other, then the associated mathematics that go
Right.
behind that, and how do you make all that happen? And so, you know, certainly today we are all very myopic once again with whatever the flavor of the day is, right? Where we used to serve vanilla, and now it's chocolate. And to your point, are we perhaps going to have a different flavor here soon? Yes, absolutely. Just like CPUs don't solve all problems, GPUs don't solve all problems. Quantum computers don't solve all problems. Each of them uniquely solves their own different type of mathematical problem. There will be others. There are going to be others. It doesn't take much of a search online to see that there are other form factors, other types of chips that will be much more energy efficient, much more compute capable, but do different types of compute. And likely you will have future motherboards that are combining the combinations of the technology like we do today. Get CPUs and GPUs on the same motherboard. They're doing different things. But the overall energy usage went up in that board. Is it possible that we have a version here in the next couple of years that substantially goes backwards in a step function in terms of energy use? Quite possibly. Or is it a case of the data usage just outpaces, which is the current trend we're on, it outpaces the compute efficiency, right? So the watt per compute is definitely improving. The energy efficiency, like, you know, to go from air-cooled to liquid-cooled, we're definitely improving the PUE in the facility. But those things they're incremental improvements and being completely dominated by the increased global amount of energy within that facility and the amount of compute within that facility. So while we're improving the efficiency, nobody can see it because we just like 100x'd the amount of power that we're using in the facility. So it's like, where's the efficiency? What happened? Why are the sites now a gigawatt?
Right.
Whereas like last year we were building, 10 megawatt sites and then 100 megawatt sites. And now we don't even get out of bed unless it's a gigawatt.
Right. You're 100% true. Well, at my age, you get out of bed for a lot of reasons, but I'm tracking. I'm tracking with you. As you're walking this back to me, and I've had a million of these conversations and been in a million of these conversations. This is where the data center owner operator in me is going to flex a little.
Sure.
I agree, but forever I have been told, if not directly, it's implied. When you think of a data center, you have the envelope, the facility, the security, the connectivity, the power. That's sort of the envelope around this thing. But what regularly folks will say, the value in it, or another way to say that is the complexity in it is the data. So I've got these systems. That's why one of the things that we're not going to spend time on it today, but I regularly love to talk about the logistics of getting infrastructure in, moving it around. My co-CEO, Tad Greason, forever talked about this. And it's one of the ways I think that it's helped our organization grow to prominence. We got really, really, really good at not just doing these other things, but in coordinating, getting that infrastructure into a facility, getting stood up with the largest organizations in the world in constant change within, et cetera.
Yeah.
But here's my point. So I build an environment, whether it's a whole data hall or just a couple racks or cabinets. It's going to live for a certain amount of life. And then what happens to it? It gets removed, it gets replaced, or it gets assimilated.
Yeah.
And so while that's operating, maybe the same team or a different team is designing the next honeypot to replace that.
Yes.
And so the complexity is within there. As the operator, though, I have to be able to, however it is that I'm doing in my initial investment or strategy, I want this building, this envelope, this property to last a really long time.
Yeah.
You might be replacing the fire trucks every so often, but I want that fire station
Sure.
to be there forever supporting this community, or as long as forever makes sense.
Yeah.
And so it's a different kind of complexity. I've got to not only be able to receive safely and do all these environments, but this thing has to be incrementally changeable over time for as long as we use modern things on our devices, or we're going to wear them or whatever.
Yeah.
So it's a different kind of complexity. And from my perspective, almost, if not equal to in complexity, near equal to complexity of these environments coming and going, because we don't know what it's going to be like in 10 years. We can kind of get an idea for 3 to 5. So how do you think about that? We just started talking about this combination of air or air liquid. For an operator like us, it's got to build these hybrid interchangeable environments that are financeable.
Yes.
How do we do it?
Whew. All right.
Take your time.
Yeah.
We've only got 4 more hours for this podcast.
Yeah, easy. All right. So first of all, we have to change our thinking. So right now, I would argue that a lot of buildings in general, the world thinks of those in square feet. So we're in 2D.
Yeah.
And most of the REITs of the world think in 2D. So not a knock against
A
any
REIT is a real estate
investment trust. Look, they are real estate guys. They finance their projects based on a real estate model, and that's the way they think of the capital that goes behind it. So we need to think like they think in part. But we can't stop there. So because the problem we're trying to solve is not just 2D. We have to think in 3 and 4D and arguably even 5D. Like, what's 5D? All right, we'll geek out on that later. So in the 3D, we've added volume, and the volume matters in a data center. So often in the past, we've seen where people didn't design the floor to ceiling height high enough, right? And when new taller racks, or we had to get more fiber into the rack, so we had to run another layer of trade in order to get just gobs more fiber in there. And now we're looking at, talking about anywhere from 40 kilowatt per rack, 120 to 600 here with the latest with the Rubin. Great sandwich, by the way, but also a 600 kilowatt rack in your data center. And then followed by the 1 megawatt plus rack. How do you get all of that stuff into that 6-sided box that you're dropping on the floor? That could be either on a slab or on a raised floor, but either way, I've got to get a lot of power in there, so a ton of amps one way or the other. I've got to get even more fiber in there because now these things, all that copper and transistors and everything that are in there are pumping out a lot more information, and I have to get a lot more cooling. So I've got to fit now pipes. I've still got to fit that same air in there. And if I'm doing a capture ratio of like 80-20, meaning 80% is cooled by the liquid, 20% is cooled by the air, it's still a boatload of air that I've got to move through the space. If I'm at 80-20 at 100 kilowatt a rack, I'm moving twice as much air to the rack than I did in my typical cloud site today, which is operating around 10 to 15 kilowatt a rack. So we're already blowing the doors off things, literally and figuratively, with my little pun. And so, yeah, it's we have to think of the problems different spatially, but then we also have to be thinking of the problems different in terms of time. So to your point, we are capitalizing these assets over a 20-year period, but then we're going to be physically changing out hardware within it at a much higher frequency. And what does that change management look like? And now we're entering into, you're kind of getting into the 5D realm of not only your change management processes, but how are you able to adapt literally all of the processes that you're putting into this whole thing, things like late stage binding decisions. So you put in enough of, I'll call it the core decisions you needed to make in order to get capital allocated and buildings built. But you've left a lot of decisions off till later until you absolutely need to. I think the whole argument with overshooting, it's unlikely that we're going to see that anytime soon being a problem. You think of all the infrastructure that's being built in the world to support GPU development, all the semi-fab, all of the mining, and there's an entire supply chain behind all of this. All of that's got to follow the same capital cycles, right? So it's not like that stuff's going to evaporate either. We have essentially an inertia to change built in by our capital systems. They don't like change to be too quick because people are trying to get their money out of stuff. That said, I think we're seeing new financial models and instruments starting to emerge. The real estate industry starting to wise up to, hey, we do have to plan for this to change more frequently. So how do we get our returns in a shorter period of time? And I think we will see a lot more creativity on that front over the next 10 years. They're going to be forced to by way of the software changes. So that's kind of how we think about it from a consulting perspective, how we design, how we commission. It's look at it in that 4D plus realm. And how do you wrap a holistic view and solutions around recognizing what does the capital need to get out of this, and how do they think, and how do the real estate guys think in the two dimensions? But how does the operator think? Back to your point. They're the guys that got to live with this thing, and they got to do these changes out via the SOPs, MOPs, EOPs, et cetera, the world we come from. And how do they make that work while, by the way, they still got to keep the facility operating and the stuff going on over here? So we're maybe swapping out a block of servers over here, running some new pipe, putting in high density stuff on this part of the building, still running the low density stuff over here. And oh, by the way, don't make any of it drop. Or somebody gets fired.
Or a 911 system's not available, or some,
it's all bad these days. I remember, so related to that, I remember at one point, people were like, oh, it's just a social media app. Remember when we had that big earthquake over in Japan? Like, one of the number one ways that people were communicating on an emergency basis at the time was through a little no-name platform called Twitter. So like, you can't discount the different channels and forms of electronic communications and what their emergency purpose may become at any given point in time. They can all be emergency anymore. How important is it to be getting real-time news on a lot of things, like the weather as an example? It's pretty darn important. It's all pretty emergency. And you know it, and your daughters know it when the second one of those social media apps drops. Dad, what's going on? Why is this not working?
It's 100% true. And with the extreme weather that we're seeing, like, as the world changes, I remember in where I grew up, primarily in California, unfortunately, every so many years, fire will come through parts of Southern California in particular. And I remember talking to my grandparents, like, why are people so surprised? Why is this so devastating? Well, because in their opinion, a period of time before, you would never build up in this area. Development wouldn't happen in that area because technology, air conditioning technology became common. Telephones, you could extend electricity and telephone up into these further reached areas. And the weather patterns at the time didn't pose a particular danger.
Low probability, high severity.
And so you could grow a community there, and you get used to these tools. When then things change or fail, you get this unintended vulnerability or whatever it is. In the same way, from a modern digital world, we get connected. So my kids, it's not exactly GPS, but when as a kid, I joined the Army at 18. Southern California, come to Georgia, had to go back and forth a couple times. I didn't have money a number of times for a plane ticket. That was an insane idea. So I would get in my little Chevy Chevette that had no floorboard in the passenger side, had a piece of wood in there, and a map. Not the book Rand McNally, a state per page, a map. Get on this interstate. Go that way till you run into an ocean. The signs will tell you, hang a right, go north up towards Santa Maria. You're home. Welcome. And so
drive-by city name.
Drive-by city name.
I remember.
You remember. My point just is that my kids run around all the time. I don't even know that they know the names of the streets in our neighborhood. Forget phone numbers of people that you call regularly. They kind of know the route that they rode on the bus to school. So if we lose technologies or there's a great impact to them, it's interwoven. That's the modern world.
I carry 2 phones, 2 computers.
Yeah, but I do too. Yeah.
And I drive a Cybertruck.
Yeah.
So speaking of not knowing the names, when I get in, it's already navigating to my destination. I have no idea.
Right.
Like, I don't pay attention to that anymore. Who cares? Like,
Right.
just get me there quickly, please.
Yeah.
And safely.
We could spend our entire conversation on this. I do want to land on something because I do not often get people interwoven into the standardization part of the world. So I just want to spend a little time. So people who aren't super nerds, if they want to skip to their detriment to the next part of the conversation, they can. We'll have bookmarks. But when you talk about your work with ASHRAE, like how are they... In the same way that the IT load is changing, the envelope of the data center is changing, ASHRAE has forever, where ASHRAE came into my world as my role in data center operations. I was a solution engineer. And so it was around, we were familiar when we were deploying branch circuits, for example, or just some standard things around basic, what we call co-location services. Very like our electricians were into the ASHRAE guidelines, and our mechanical folks way deeper than we were. How does an organizational body like ASHRAE keep up, or at least attempt to, with clarity, inform the industry? I couldn't help but think when you're talking about the investment coming in, how does an investor, like, are you investing in an operator in the envelope? Are you investing in the people that are deploying the infrastructure? How does that guide you? How do you even learn the lexicon? And then you've got the people that are helping to inform us from standardization on how we should do it. We don't want mud. We don't want static electricity. We want safety, and it's got to be on. So what's ASHRAE's role, and how do you keep it relevant?
Okay, so maybe it would help a little primer on where
Please.
this stuff even evolved from. So ASHRAE is made up of a lot of different technical committees and standards committees. The technical committees help write a lot of publications and guide research, and ultimately are contributors and sponsors towards the standards, which are ANSI approved, so they can get adopted in codes like the International Code Council or the ICC codes that are published out there. So back in about 2004 timeframe, 2 gentlemen by the names of Roger Schmidt and Don Beatty, who was the original founder of the company that myself and my business partner Neil Shahan own these days. Those 2 got together and said, hey, we need to start this committee. And it wasn't just because they had a great cup of coffee one day. There was this new technology that was coming out called a blade server from IBM. Right? And everybody was like, oh, wow, this thing's a lot harder. How are we going to handle this? How are we going to get everybody on the same page? Right? It's a common theme. How do we get everybody on the same page?
That's right.
So they brought together essentially a consortium of the IT OEMs from all the big manufacturers, got them in this what started off as a meeting group or what have you, but eventually formed into a technical committee. And they got them all together and said, hey guys, what do you think we should do for a quote unquote common platform interface spec? So you're going to put these pieces of hardware in a facility. How do the facility guys know what you need to make that work and be successful? Because like IT guys don't talk to facility guys, right? You might have heard that one before. Yeah. And so the idea was, if we got all those IT guys together in a room and got them to write down on paper, hey, here's our box, and we just need you guys to come meet us at our box in this way. Bring this type of air temperature to it. This is how we're going to hook up all the interconnectivity to it. This is how we're going to hook up the power to it. But ASHRAE's purpose in life was really to solve for the cooling portion of that, right? IEEE and other industry committees do the other pieces. And it's why we have standardization around Ethernet ports and all that other stuff. Right. So the standards committees play a really important role in basically trying to set the collective framework that we can all play by without giving away secret sauce. And that is really ASHRAE's charter, and in particular ASHRAE TC 99 and the publications that they put out. And in order to stay relevant, they decided, hey, let's not put all this in a standard, because standards move really slow, right? If you think of like how rapidly do the codes change. Well, they come out with new versions every 3 years, but not everybody does it at all at the same time. It's really slow. So what they decided early on was to just publish books and technical bulletins and papers because you can do that much quicker. You don't have to go before a committee and go out to public review and do all these things to get consensus. Rather, you try and get consensus via the people that know within that group, publish it really fast because by the time you publish it, it's stale. You need to publish something else anyway.
Right.
So that's kind of the premise and the background behind ASHRAE. Now, other technical committees, they don't move, or I'm sorry, other technical committees in ASHRAE as well as other industry groups don't necessarily move as fast. I mean, we still don't have the USB ports fixed, right?
Right.
50% of the time I get the darn thing the wrong way.
Right.
You know what? At one point they were supposed to fix that to where it didn't matter and any idiot could flip it either way and it would go in just like a USB-C cable.
Right.
I still can't get over that, right? But there's an example of how standards committees move too slow to keep pace with technology and why what ASHRAE is doing is really useful and differentiated from the rest of the market so it can move really quick and stay up with the software changes. But here, you know, this actually leads into a bigger problem.
Okay.
And so I'm going to dive right
Let's
into
do it.
The bigger problem, you know, our industry, we have this kumbaya in the data center market, right? And all the people that are coming into the space from outside the data center industry these days, they're like, man, you guys are cool. Not just because of your hair and you love to surf and do whatever else, but you guys are really cool. You all get along.
Right.
You guys all talk. You all know each other. How is that? Like, you know, whether they're coming from oil and gas or, you know, pharma or wherever they're all coming from. And we're like, well, no, I don't know, man. It's always been that way. And I think the reason it's always been that way is look at our roots. We came from telecom and we came from hardware development. Take the motherboard on any server, whether it's a router, a server, a switch, a gateway. It's made up of a whole bunch of different components from different manufacturers. So there's no one stakeholder you can point out on the motherboard and say, there's the key to success. No, you had to get a whole bunch of people, a whole bunch of companies together, and you all agreed, hey, we're going to make this thing work in order for it to be successful. And you had to do that again and again and again, really, really fast. That's the speed of the market. Telecom, same thing. Didn't matter. If your fiber is great between city A and city B, wonderful. But if it doesn't work all the way from city B to C, C to D, E to F, F to G, all the way out to Z to the West Coast, not that I'm saying, you know, West Coast is associated with Z. It could be the other way around, just to be clear.
I'm with you.
Then it doesn't matter. So the telecom industry also had to be like, kumbaya. Guys, we got to work because we're all interconnected. You get an outage, I get an outage. He gets an outage, I get an outage. She gets an outage, I get an outage.
Right.
Data center software came along. They learned real quick, same thing. Hey, we're made up of the telecom guys, we're made up of the hardware guys, and now we've got the software guys in the mix. Oh, yeah, I guess we all got to play nice together or this doesn't work. And so I think it's that, I think those are our roots that made us where we are. And I'm sure I'll have wonderful debates in the industry now, and now that I've put this out there and where my true beliefs reside. And so I think that's how and why we are the way we are today. That said, I think there's a big trend afoot. And this is the elephant in the room. And this is the unspoken, I think, common denominator to a lot of the problems that the industry is now having. And that is it's kind of like growing a business. You grow too fast, you get too many new people in. I'm living this right now. You have major culture dilution. And so how do you manage that? And what's happening in the data center industry is we are now that really rapidly growing business. And everybody and their brother from every other market is coming into our space. Well, they don't share that same cultural background. They didn't work on the outside plant. They weren't coming from an OEM, manufacturer putting pieces together on a motherboard. They don't get this kumbaya thing. And I think that dilution of our industry culture is leading to a lot of siloed approaches and thinking and protectionism. Hey, we have to carve out our stake in the AI world. Well, guess what, guys? We're all interconnected. That model doesn't work. And I think it's manifesting itself in a lot of really ugly ways now. You know, I've noticed even recently with industry conferences where, you know, it used to be, hey, I could get up on stage and have representation from hyperscalers and OEMs and this and that. And now they're like, no, we can't do that anymore. I'm like, what? What are you talking about, man? We've been doing this crap for 20 years together.
Right.
And you're telling me now you're not allowed? Like, what? They're like, yeah, we're not allowed. We don't know. I'm like, this is not going to go down well. We can't make, you know, we can't make this liquid cooling thing. We're in a realm now where this is more complicated than it's ever been for all of us. Liquid cooling is a really hard thing. We brought what we do over in the pharma industry into the data center industry overnight and said, hey, make it work. Oh, by the way, but it's different. But it's no less as complex. And we're now, you know, we're doing that in the midst of there's no standards for any of this stuff. There's no like goalposts. There's no kumbaya anymore. And I think when you take all of that together, we've got this perfect storm for really big mishaps to occur and honestly throttling the rate of growth and success of the industry in itself. You could tie this back to things like the water problem. Here we are as an industry. We are standing up gigawatts worth of AI data centers. So arguably, we're some pretty smart dudes. But you're telling me we can't solve this water problem? Really? Really? So, you know, I put an unpopular post out on LinkedIn a while ago and said, hey, why don't we do this water usage credit? And they're like, what? I'm like a renewable energy credit, man. We already do it on the energy side. Let's just do the exact same thing on the water side. We all pay in a credit for site usage of water so that credit, that money goes into investment in sustainable water infrastructure. Let's build more reservoirs. Let's build more dams. Let's figure out other technological ways to reduce the evaporation on site. Some of this stuff already exists. It's nothing new, but it's not rallied around a common thesis, a common idea that we can all come behind. And this is back to the root of what I think is all the problems that we're experiencing in the industry right now. We don't have standards because we don't agree to get together and write them. It's not because we don't have smart people to do it. We're all just like, carve out, nope. Because we have this massive cultural dilution in our space and everybody not realizing, guess what? You go, we go. You fall, we all fall. We're all interconnected. On the telecom level, on the hardware level, on the software level, on the infrastructure level, it is all one big connected internet.
Well, I want to ask and interrupt. A lot of it is resonating with me, but I got questions.
Yeah.
So
I know it was a hell
that's
of a
okay.
monologue.
No, it's great. And it's healthy. Like we should have that conversation. So let's back up. So I would agree with you. At least I joined the industry in 2004. Before that was at the University of Texas, hook 'em horns for about 8 years in the IT side of things. And even in the IT world then, so not really how IT integrated with or communicated with facilities, there weren't a lot of, there were testing agencies to get Novell or Banyan Vines or Microsoft or fill in the blank certified or Ethernet or TCP/IP or whatever.
Yeah.
But most of my training came from OJT or gaming or people coming out of the Navy and to some degree the Air Force. And it was spectacularly collaborative.
Yes.
Hey, I got this thing going on my Novell server running on Microsoft Post Office back in the mid-90s. I'm not sure. And my Navy friends would come over. Ironically, almost all women were the most collaborative, far and away. It was very cool. And they would come over to the campus. I worked at University of Texas Medical Branch, and they would help me solve the problem. We worked through the manual together, and away we go. They weren't even necessarily in my department. We were all at the same university. But so there was a lot of collaboration. There was a lot of help. We didn't even have firewalls on the T1s coming into our campus. It just didn't exist. So that was a long time ago. When I came into the data center space, it's exactly as you described. The third group were like the big construction firms that had a lot of experience building life science or other critical infrastructure, and they took safety very seriously, obviously, SOPs and MOPs. That's why we would, and still do, attract a lot of veterans that come out of not just mission and purpose, but what's the process and procedure? We would call it commander's intent, which we talk a lot about around here. Here's my Uniform Code of Military Justice, the Geneva Convention. Here's how I move through my mission and troop welfare.
Yes.
Am I tracking so far?
Yes, very.
Okay. So there's still a lot of competitive angst, and I'm stronger and elbows out or whatever, but we weren't sharing necessarily.
No egos in the room here.
No, yeah. Zero egos. But there was standardization on how to get certified to drive an earth mover or to touch high voltage or hot or cold water or to do urban planning, all of these things. And the city or the county expected it. And if I'm going to be an employee, I expect you to have operational maturity. So that was the landscape. And I think to a large degree it still is. But where big change had to happen, the one that comes to mind for me was, so we would inherit change, to your point about ASHRAE or whoever. They would make the infrastructure. So IEEE, what's going to end up being a routing chassis or the the OSI model or whatever. Like, we weren't responsible for any of that. We would just inherit the stuff to go in a standardized rack that we could power and cool. All right. But eventually, the conversation around power utilization efficiency, an imperfect idea, but where I'm going with this is people talked about this idea of sustainability and being greener, and it'd be better if you had blanking panels on racks or things like that, but it wasn't really enforced until attributed to Christian Bellotti over at Microsoft. I don't know who the committees were, or Dean Nelson or whatever, but some group of people said, we will not allow you to bid on an RFP or whatever if you do not have a framework in place for communication like ITIL, a PUE policy that's actually published and been evaluated. We now call it ESG reports, but evaluated not by you and not by your
independent
customer,
yep.
a real, it doesn't have to be a top three, but a respectable one that these are the things. And so they did what Dean Nelson would call a forcing function. You got to do this.
Yes.
Or we're not doing business. And so people did it. We did it. Everybody did it.
Yeah.
Why, I guess, in the midst of this, so operators like myself, I want to build a safe environment that's good for the community. It's good for my customers. It's good for my employees. It's good for my investors. It's good for myself. I want to do that. How much in this world that you're talking about is on those big customers saying, this must be a requirement in order to do business with us? Because back then, when you're describing, they did their own data centers primarily, and they would outsource the overflow to an operator. Now, things are moving at speed and scale that I don't know what % they do themselves, but as significant is done by somebody else, because that's our expertise. They're doing the software or the hardware within it that they're bringing to environments like ours. What's that combination look like? That it's not just the operator, it's the customer going in there that's forcing this to happen.
Let me pull the mic a little closer.
All right.
I have to ask your question with a question. So, new conscious strain of thought here on this topic. Mm-hmm. Have not talked about this before, have not posted
realizing
before.
This could be completely edited out.
Yes, 100%. Who does dominate the market anymore? And you don't have to answer that. I'll throw my take in on it. Nobody knows. Mm. And I think that's part of the problem. Mm. So rewind a few years, everybody had their well-defined stake in the ground. They had moats that were really well-defined. Mm. everybody knew what the Microsofts, the Googles, the Metas of the world did. And along came AI, and that all just got completely upended. And I think if you look at the market today, we've got an identity crisis amongst all the big players. And even more so, we have, look how many new big, quote unquote, hyperscalers entering the space now. There's a lot of them, not naming all the names, but we all know that who they are and how they're getting into the space. And so I think that's part of the problem. You don't have that well-established player that can say, hey, I'm the big brother in the neighborhood, and I can go ahead and help drive the policy and the change in the marketplace anymore. I think in this AI realm where we have this identity crisis of what does everybody own and what do they control, it's hard for anybody to stand up on the playground and say, I'm the big guy on the playground here, and I'm going to set policy for the market. And so, I think that's working against us in a big way. And in fact, that fundamentally could be the answer to the prior issue I brought up. And why don't we have this kumbaya anymore? Nobody's keeping order on the playground. We got like 10 new bullies on the playground. Nobody knows who's the toughest guy on the block. Nobody knows which corner of the playground is whose. And it's just a state of chaos. So in that state, where's the standardization? It's now we're all kind of like fighting and protecting, and I think that's what's ultimately leading to a lot of the challenges and the struggles that we're all experiencing right now. As a consultant and as a licensed engineer, I have to default to what's the quote unquote standard of care. What's published? What did we all agree to? And right now it's like, well, I don't know. The only thing we've agreed to is to disagree on pretty much everything. Do I build the whole site for just air cooling? Do I build it to be able to take 100% air cooling and 20% liquid cooling? What density cabinet do I design to? Do I put equipment on the roof or not? Do I use water or not? Everything's up for grabs. And now we've said, generators, recips, not sure. Maybe we'll do natural gas combustion turbines behind the meter. Maybe we'll do combinations of that and interconnect to the grid. Maybe we'll throw some battery energy storage in there too, right? Just for fun. So we've really, we've introduced tons of new technologies, not just at the software layer and the hardware layer, but now with the cooling systems, now with the power systems. And so we've upended everything all at once. I love it personally, because I'm that kind of crazy guy, but in the midst of chaos, there's lots of opportunity. And, we see tons of it. We like the complicated projects. We like helping customers figure all that stuff out. But at the same time, it's really created this high risk, high stakes. Where's the direction? Nobody knows which way's up. And that is manifesting itself in a lot of really crazy ways, and many of which we're all still trying to figure out. Like, what is this gray matter over here? Do you guys feel that? You see that? Yeah, we do, but we don't know what it is yet. And we all feel it. Those of us that have been here for a long time, we're like, we kind of losing our mojo and the kumbaya we used to have. Like, what's going on, guys? All right? Yeah, we're all feeling it.
I hear what you're saying. I know internally, like my facility teams, my operations teams, they seem to be pretty confident in what they're building. When I talk to my frenemies in this space, they seem pretty confident in what they're building. In other words, I don't feel them, at least from the data center envelope infrastructure, for sure. Is it liquid? Is it air? What's that going to look like?
I have one simple question.
Sure.
What S-class you using, man? What's your S-class?
You're asking the wrong person.
Yeah, no, but I just ask anybody in the market right now, what S-class you use?
So describe what you mean by S-class. You talked about it briefly earlier, but what does that mean, and why is that question relevant?
Well, so back to the roots of ASHRAE and the thermal guidelines. So we started off with a platform interface describing the entering air temperatures on the racks.
Right.
So all we did was tell the OEM market, hey, man, we're going to give you this temperature of air going in. You figure everything else out. And once we gave them that information, or the other way around, they could design the thermal architecture of that server around that information. And so there's a lot of decisions that go into the design of that hardware once they know that entering temperature. And if I don't maintain that entering temperature, it changes whether or not that server can operate at that compute level, you know, that its throughput, as it were, with the number of bits and bytes. And so it's important. And SLAs to this day are still written around those entering temperatures. We have a recommended range on a psychometric chart followed by allowable ranges. And all SLAs out there today follow the recommended or the allowable ranges.
Sure.
S-classes, we've done the same thing on the liquid side. So basically we've said, hey, here are the entering temperatures on that liquid, that server level liquid that we're going to run through a cold plate that's on top of that GPU. And here's those acceptable temperatures. So we publish that, put it out to the market, and what's everybody say? That's nice. Thanks. I don't know. We can't agree. We can't agree. Well, geez, the guys over here designing the infrastructure, the colo guys in between, the hyperscalers and the OEMs, we're all singing from a different sheet of music. That's a bit of a problem. You know what else is a problem? In the air-cooled server worlds, everything's integrated on that motherboard, meaning its means of cooling itself is built within the algorithms that run the fans on the motherboard. So even if I muck up something out here in the room, that server board is going to either ramp up those fans to help cool off whatever peripheral on that motherboard is overheating, and or it's going to throttle the electronic process on one or more of those pieces on that board so that everything still works in harmony, I stay in warranty, and I don't burn everything up.
Right.
Well, now with liquid cooled, we've decoupled. We've taken that fan that was on the air cooled and we put it over here in a CDU, or cooling distribution unit, that serves as that interface between the facility water system or your central chill water plant and the server cooling to the cold plate on the GPU. And we've said, yeah, these two aren't going to talk to each other anymore. They're not friends anymore. What? So now not only have we decoupled those and they aren't talking anymore, we can't all agree on what the temperature is that needs to be going into the server from that loop. Even though we've published something, ask anybody. Ask your operations guys. Ask the design. What's your S-class, man? What's your S-class? You want to get one quick, simple indication, one question that will prove my point that the entire industry right now doesn't know which way's up. Ask them their S-class. And see whether or not it lines up to any one of the published values that came out of that publication from ASHRAE. That's what I mean by we're in a state of chaos.
Yeah. But isn't that, I guess my question is, or as I think about that, so you're having a conversation. So involved in this are the infrastructure where, you know, a customer's deployment lives, whatever that might be. You've got the manufacturers of the power infrastructure, the cooling infrastructure, whoever that might be, the Vertivs of the world, the Schneiders, the whoever, Stoltz, I don't know, Train. You got that group. And then you've got the people who put the envelope around it that are putting out there. And how have you seen the conversation happening between, I've seen a number of them where I've seen the manufacturers and they will have in their innovation council conversations, here's the equipment that I'm going to go install with a data center operator. And they're going to be able to have a range of capacity that looks like this, handle this much heat, it's going to be this much physical footprint, et cetera. This is how you're going to service it, whatever. And so now you got one of the consumers of that. So we wouldn't be a consumer. We're the envelope that wraps around the things. We bring in this infrastructure, we put it in there. The customer connects to that. That conversation, that orchestration takes place. Whether it's a Hyperscale or one of the other organizations, how are those conversations being facilitated where they're thinking about not just, you know, the conversations have already taken place about what's being deployed today. These are for conversations in 24 or 36 months. how are those conversations? They are obviously standard. I don't know if standardization is the right word, but they're deciding on something. These are the operational parameters. This is going to go into this much of a physical footprint. It's going to operate like this, or they wouldn't do it. They're not unsophisticated. So how does that happen now?
In a very time-dependent conversational way. And what I mean by that is most decisions in the market right now are driven by time. Meaning it's as much about, hey, what do you have available like in the next 6 months, 12 months? Okay, great. I'll take it. It's not, hey, what do you have available? And oh, by the way, I need you to provide this criteria. And they're like, well, I can't do that. I can't do that in your time frame, right? They're not sitting there saying, well, I'll wait.
Right.
It's like, we'll take whatever you have, we'll figure it out. And what they mean by that, translation, is they'll hand it over to the consultants like us, and they'll say, here's what the manufacturer has available. Oh, by the way, we already bought a bunch of it and put it in a warehouse. Here's what the end user or customer may be asking, and here's what we put in our SLAs. Can you make all this work for us? And oh, by the way, get it done like twice as fast as you did before. And that's where we come in. Is like how to be the matchmaker of the chaos. So that's my view of where the market's at right now. And again, we thrive in that environment of opportunity. There's lots to do. It's a lot more fun, honestly. Doing air-cooled data centers at 10 kilowatt a rack or 300 watts a square foot was getting quite boring. So I'm glad something came along and kicked the chessboard over and made it a lot more fun. But at the same time, the risks have elevated for all of us because of that chaos and because of the lack of the standardization. And I think, let's zoom out further. Aside from us all hurrying in this AI race to build the next largest language model or the next best inference data center or whatever, what else do we have to solve here? And I think we have some much bigger problems that we need to be tackling collectively, and it's nothing that anyone's standards group can solve. It's nothing any longer that any one big organization can come along and solve. Like the work that Christian Bellotti and Dean Nelson did back in the day, wonderful, right? But I don't think companies are in the position to do that anymore. Because again, nobody has that space carved out like they used to. There's no more moats. And so I think we need the emergence of something else to help us solve these bigger problems, like the water problem, like the power problem, like the energy efficiency problem. We're still consuming and creating tons of carbon out there, right? How do we solve for that at a much bigger scale than what we're doing right now? How do we come up with heat recovery strategies? Without going into that detail here, there's a lot of physics working against us with using silicon-based processors. In order to go higher temperatures, we're having like compressed delta T's and other things, and we only have so high we can go before we start like shooting ourselves in the foot. And so there's bigger issues on the plate now. Us lowly consultants, we don't have the tools to solve all of that, though we're trying as hard as we can. And I think something new needs to emerge to solve it. I did a post once where, maybe it was just me being an optimist for once, where I said, maybe the answer is we not try and solve all of this right now, why we're all in the rat race, building all these as fast as possible. And what if the answer is we get a whole bunch of this stuff built and superintelligence emerges and gives us all the answers to solve all that stuff. And we just wake up one morning and it's like, boom. We didn't have to form committees. We didn't have to come out with public policy statements. We didn't have to publish standards. We created superintelligence, and superintelligence just tells us, hey, man, here's how to solve all that. All right, humans, go on and live a good life, right? I know, that's the super optimistic outcome, right?
Super optimist. Let me ask, I'm a pretty optimistic person, and maybe I'm thinking about it wrong, but this is what it reminds me of. Unfair analogy, perhaps. I am a farmer. It's turn of the 19th century, and I have a 3-acre farm that I got myself and my 12 kids. I got the plow, I got the ox or the horse or whatever, and an internal, some mechanism, internal combustion engine or whatever. And all of a sudden now, I've got the ability to make a larger farm. I can, the reason why I don't have more land, or maybe I have the land, but I haven't cleared it to create more farmland, is I just can't get it seeded or tilled and seeded and then harvested. And there's a period of time, and I know I'm romanticizing, but I'm just thinking out loud, where one of the reasons why we would get together either on Sunday or Saturday, one weekend, was to have these communications. How are we going to help each other at harvest time? How do I get my kids introduced to your kids so that they can start their own families? How do we come together to raise a barn or do these other things? There's imperfect, but collaboration. And there's no way we did it in silos. You couldn't defend yourself. You could protect yourself from the elements or other people, whatever, if you didn't do it in community. So we did it in community, but we managed our plot, whatever that looked like, with occasional help from our neighbors. And if you wanted your neighbor to help, look, your bales of hay had to fit in their wagon, not just your wagon. Like, these are the things, whatever that common denominator was. But then there was a disruption. Innovation came, and all of a sudden, some people could afford to do it, some couldn't. Some things raced ahead, some didn't. There were winners and losers. There was chaos for a while. Are we even shoeing horses anymore? Are we even doing I don't know. But the consequence, if you look now, some amount of time later, fact-checking a data center podcast or not, using an agriculture metaphor, but what I heard not long ago was most of the world, a significant portion of the world, is fed by the United States of America. And global hunger and poverty has greatly decreased because we've got this food going out and all these other things. So there is a period of time where the agricultural community that had evolved from Western Europe here in America, that followed traditional norms, that did things a certain way, and then there was a unbelievable explosion of innovation, plus transportation of getting that through railhead and other places to these other things. And there is all kinds of things going on. The ultimate, in my opinion, result of that is for good. Yeah. So are we in a season like that? Because you and I know we work in not just the company that I love and have been part of. You're heavily involved in this industry. It's been great for you personally, and you believe in the big macro. I know you do, David, and that's not, you're not saying not that. How do we, while we're being disrupted by this innovation everywhere, innovation in the chips, innovation in how we power them, innovation in how we wrap them, innovation in logistics, all of these things. And oh, by the way, there are other nation state competitors. And I don't know if it's true, but there seems to be implications for being a first adopter in a way that there wasn't before. That might be an exaggeration, but it feels like innovation in energy or lack of it. All of these things, let's just ascribe a motive that everybody's all in. We love that good old day collaboration, however it came about, and we want it again. But at the same time, we got to eat on the way to paradise. So as you're thinking about this and you're in your most optimistic tone, how do you, in a winsome, elegant way, win people? How do we do that together and make sure? Because we're also going to communities and saying, hey, look, we want to help you. And these are the things that we're doing. And we want them to believe in this big idea. So I know you've thought about this too. How do you think about it?
Whew, that's a big question. Well, I think about it in a few ways. One perspective is, look at the connectedness in the world right now. I saw a stat not that long ago where there's far more smartphones on the planet than there are humans now, active, connected to a network, smartphones than there are humans.
Well, there's 4 phones in this room, and there's only 2 of us.
Case in point.
Right.
Case in point. Are we the oddballs? I don't know. Right?
No.
But you mentioned the hundreds of media channel options that you now have available on TV and the hundreds that are embedded within those. The connection and the outreach that exists in the world, that in itself is just tremendous, right? So this technology, this enabling technology has helped in so many different ways, and probably more so, the other crazy stat. There's more people that have a smartphone than have clean drinking water or clean sanitary facilities, right, globally. So clearly, the world has decided that is more important. Having that connection to other humans and having that connection to information is more important than those other 2 things. And so if you look at it in that context, artificial intelligence, I made the joke when it first came out and, aged myself in doing so because a lot of people didn't get it. I'm like, I have data sitting next to me. And they're like, what do you mean data? Like, of course you do. I'm like, no, data from Star Trek. Like, I'm like, right. That data. Hello. Right. I've got 3CPO and an R2D2 next to me. Like, I can ask any question and I get an answer instantly.
Right.
And I get a comprehensive one.
Right.
And just fast forward 2 years, now I'm getting versions that are like, it's from 20 PhDs.
Yeah.
And so that level of information diffusion globally is a really, really positive and powerful thing. What's better than giving a man a fish, teaching him to fish? Well, you could argue giving them all the world's information in their smartphone, well, they're going to figure out how to get clean water. Like, there's a million innovative ways around the globe to do that, that now somebody out in a remote part of Africa can go on YouTube and like find those answers and be like, shoot, I could do that version where I'm at.
Right.
So I kind of view it in that light, that this is the ultimate enabling technology, that there is no limit to which we've ever like said, oh, I'm smart enough now, right? Mankind, myself, you, we've never stopped and said, you know what? I've learned enough. Now, we may have said, you know what? I've eaten enough. Or, oh, yeah, I've got enough cars. Or, oh, yeah, I've got enough property. But nobody ever says, oh, I'm smart enough now. Nobody's ever done that.
Right.
And so mankind...
Not the smart ones anyway.
Yeah. Nice. And so I don't see an end to that trajectory. And I think what we're creating right now as an industry is the ultimate enabler to answer like all of these issues. We've talked about trying to solve for world hunger and all these things.
Yeah.
Well, guess what? We're doing it. We're doing it via this other instrument. Everybody used to think, well, it was we just need to distribute more food. We need to grow more food here in the U.S. and send it elsewhere in the world, to your earlier comment. No, that's probably not the right answer. We're creating lots of other problems doing so. Like, that's a huge carbon footprint with all the food miles.
Or it was a point-in-time answer, but now...
Point in time. Right. That's right. Yeah. So it was the right answer at the time.
Right.
Stage appropriate.
Right.
But I think right now, the AI race that we're in is also stage appropriate. And I do think in a lot of ways it is very analogous to some of the evolutions we went through before, and hence why we're calling this now the 5th Industrial Revolution. I spoke with Nancy Novak up on stage on this very thing.
Yeah.
And I had
brilliant mind.
I had a 5-minute warning, by the way, literally 5-minute warning. Dave, I need you up on stage with me. Like, what's the topic? Oh my gosh. Okay, let's go.
Nancy, we're going to take a detour just for a second. I got to have dinner with her a year or two ago in San Francisco. It was so much fun. We agreed on a lot. We didn't agree on everything. She's such a fun, thoughtful, wildly experienced person.
Yes.
And is willing to engage without, one of my favorite things, I want to engage even when we disagree without breaking up. Like I'm not assigning a motive.
We can agree to disagree and it not be in a hateful, mean way.
If we reach an impasse, let's move to the next thing that either we're celebrating or we're having more fun with. So she's one of the fun ones. I guess to interrupt your thought for a
Sure,
second. So
sure.
here's my question. So we're in the middle of this, and I don't want to be as dramatic as saying we're putting out a fire and we're trying to talk about how do we collaborate while we're running the bucket line. I don't know to what degree. Certainly there is pressure on all of us for one reason or the other.
Yeah.
So how do you capture the imagination of these different constituency groups? The my end customers that are going to live inside my data center,
Yeah.
the manufacturers that are building the components that are going to go in to help power and cool and connect and whatever the systems within the data center, operators like me, consultants like you, and then emerging, I think importantly, the communities that we live in where we agree on the macro idea, this is for human flourishing. We don't, if your relative or maybe you is benefiting from a tool, whether it's AI or otherwise, it's helping look at a film from your surgeon or your doctor to help extend your kid's life or do these things or solve a problem, we're 100% on board for that. We're talking about not that good, but we're talking about a technical a technical problem as much as it is a business problem, and collaboration to get standardization. In other words, I want to bring a box of Legos, but I've standardized on what the dimples on a Lego look like, how they click together. Now with the box, you can snap them together in any way you want. I don't even need to give you a picture. Your imagination could be the picture. But what I have standardized on is these 8 or 10 shapes, and they can be formed into Godzilla, a race car, or a house. So how do you get people interested in, while they're under this speed and scale pressure, to sit down and also add to their 2-phone busy schedule this need to look more like that collaborative era than the let's get the harvest done right now era?
You know, you've made me realize that maybe we're trying to solve the wrong problem. Maybe the right problem is abandon standardization, abandon collaboration altogether. And I know that sounds like I just did a crazy Ivan on you, because I did. I did on myself too.
Did we just go to hunt for Red October? I don't know what just happened.
We did.
Okay.
But I think that's one of the enablers of AI and of a higher order of intelligence, even for ourselves. Is like, I did a post here recently where you and I are able to digest multiple PhDs, thesis for coffee anymore via just a quick prompt, and I think that perhaps we're in an era where the standardization piece is no longer relevant. It's no longer necessary. And maybe this great divergence of approaches and ideas is the right answer. And I'm literally self-discovering as we're having this fascinating conversation. And I think that we could have been on the pursuit here of trying to solve the wrong problem. So I have to just delete the last few years of my pursuit and start all over is what I'm saying.
Maybe, I guess my question is, because there's no way I'm getting on an elevator that doesn't have standardization, whatever its future form looks like, right?
Yeah.
And we're not, like, when a facility is built, it is not built without regulation. So that's not what we're saying.
Yes.
Code enforcement happens. These things happen.
There's still some baseline stuff.
I still think that data centers are an example of one of the best examples of platforms of innovation and efficiency. And all I mean by that is the way that we do entertainment, the way that we do education, the way that we do climate change analytics is happening in a data center somewhere.
Yes.
Coca-Cola's formula is in a data center somewhere.
All those media channels we talked about.
So the things,
everything,
all the things
is in a data center now.
Is in a data center. The other day, I was listening to somebody I couldn't quite understand, so I went to a couple different translation tools and said, "Here's what they said, and here's what they wrote." And I didn't have to find somebody who spoke Thai or whatever. It helped me imperfectly, perhaps. I'm not saying, like, I wouldn't base policy on it. But this is my point. I don't think it's a forever thing. For sure, regulation is happening and these things are happening. I think there will be an outcome.
Yeah.
Because we're going to trend towards efficiency. We're going to trend towards
no question
elegance. We're going to trend toward it. Has to. You won't get it financed if it doesn't. But if you're in that disruption season, we're in disruption season.
We are.
And that's what it feels like now. But I still...
Which is also opportunity season, by the way, right? For all of us.
Yeah.
And that's a good place to be.
Yeah. But I want to, what other things I love, David, that you, besides your passion that you bring, and I've heard you say this off the stage and on the stage, is at the very least, we should be thinking about it.
Yes.
We should be thinking about it.
We have to challenge
and
it.
And how do we come back?
Yeah.
And how do our customers that are having these behind the scenes conversations, they'll get on stage or they'll get in a conversation like this and they'll have a public facing, but they'll also behind the scenes. I know they do this sort of back to my Tom Clancy reference. He always had somebody that, somebody at the CIA could call, somebody at the KGB. They had some back channel thing or whatever it was, real or imagined. But you could sort of have these so we can resolve misunderstandings or find a way forward.
Yeah.
I know that happens to some degree. I think that it's people like you that continue to say, look, whatever season we're in now, as we find our way through it, let's not forget we also need to build along, whether they're pouring into ASHRAE or other ancillary things.
OCP,
all the things, because
grid.
this is ultimately where we land at the highest form of efficiency and effectiveness is in standardization.
Yes. We're going to continue to fight the good fight on that front. Don't get me wrong.
Yeah.
But I love challenging my own thoughts on things, my own thesis, and saying, wait a minute, maybe you're fighting the wrong fight, dude. So I think it is one part of each in the equation. I do think that some level of standardization, and that was the original intent. Let's agree on the platform interface spec. You're going to bring the box to the building, and I'll bring everything else. And I think the way all of our roles in the industry, whether we're equipment manufacturer, or contractor, the consultants like us, or you're the end user, or you're the colo, or you're the regulatory body, or you're the property owner, right? The power provider, we all need that interface defined. We all need to know, hey, you want that thing? I know how to hook up to that thing. And I think that's where we need to come together as an industry, and then perhaps at a higher order, we need to come together on how we're going to do this more resource conscious. Right? We need to wrap back around the ESG concept and improve the energy efficiency, manage the carbon better. All of that is still going to be relevant for all of time. It's physics. Yeah, I think it's one part of each. There's
One
no
of the things
question.
that I love that you do, I know you're doing this, you will meet with OEMs or data center operators like our company or whatever, and you'll go, we have innovation summits. We have different ideas where we come back kind of behind the scenes.
Yeah.
Hey, are we on the right track? We do collaborations or whatever, and you participate. And one of the things I've heard by reputation, and I've seen you do some version of this, which is, look, sustainability, like for your kids, for my kids, for whatever, who wouldn't want a deployment that meets these different goals, or for standardization, for safety, all these other things. We want to do it. We're in a season of opportunity now. We're moving this way. One of the things that is hard to do for some people, it is not hard at all for you. I don't know if that's good or bad. I don't want you to take your shirt off, but I'm sure you've got the scars to prove it. Is this, hear what you're asking for, can be delivered. At the same time, I'd like you to consider this. Have you thought about, for example, you've mentioned in this conversation commissioning. I heard somebody do this last year. Have you considered some remote commissioning? And the people that I heard on the platform were like, you're crazy. We don't do that in this industry. There's no, and the person said, it was not you, said, well, here's what I can give you. I'm not saying 100%, but if you'll let me, with a team of experts that's based in some part of the country, do 12% or 20% of commissioning remotely. We'd have to agree upon a standard or whatever. We'd have to sell it to your customers because they'd have to believe that this commissioning. But I can now help you hit the sustainability, the speed to schedule for opportunity to get those electrons working quickly, all these other things, these safety things, and the workforce problem that we haven't talked about at all today in terms of getting talent involved there. In the same way that we just said a little while ago, we wouldn't do multi-story or have perforations of the top or run liquid into a thing. It would take me forever to try to explain why there's a sprinkler head in there, much less any of this other stuff.
Yeah.
And so people like you are able to say, yes, and yes, I can, and, or, but if you consider this, this is how I hit your economic, sustainable, and all these other things for you to consider, still with a wrapper of excellence and performance and SLAs and whatever, but you should consider that. If you don't, your competitor will. And I think so that may have to happen behind the scenes.
So first things first, I got to make sure I have my phones here because did you tap my comms?
I did not, and we have not talked about this.
Okay, cool. So it's almost like we have a neural link going on. I love this.
I feel bad for you if that's the case.
Well, no, I was going to say I feel bad for you. We're both in trouble.
We're both in trouble.
So yes, absolutely. Not only to think about it, we're already working on it. You look at things like, so on a trial basis, there are fully automated surface mining going on already. So basically these deep pit mines, right? They've created autonomy with the big dump trucks, and they got remote operators on the trenchers, and they have a fraction of the people or no people. You have fully automated shipping ports over in China right now. Nobody there, right? So you might have a man in the middle running a joystick on portions of it remotely, and large portions of it running fully autonomous. But those are just two examples, right? So you say you have those, and then you ask me, do I think we can do commissioning without being on site? Of course. You'd be a fool to see those examples and say something as simple as this, that you couldn't also do it. But it comes down to the right economies of scale and the right, transformative change with technologies. The large portions of the technology exists already. And I hate to even make reference to it, but, we're seeing versions of it already over in the Ukraine war with the drones and everything. And if you think, well, I can use those same drones and devices for good, though. And I can use them for remote monitoring and, if I want to do IR scanning on a piece of electrical gear. So rather than
fly the roof on an August day to look for thermal anomalies, I haven't displaced.
100%.
I am still hiring roofers. I still have them. They're not disrupted. But now, instead of walking my 4 million square feet of roof on one campus, they're going to fix the problems. I'm not sending robots up there. I got people, but I got these drones flying a flight pattern that can tell them.
Yes. And at some point, the humanoid robot piece, sure, it's all coming about as well, right? And that is going to displace some other jobs. But the way I frame it and like to put it to others, there are many other jobs being created in the process. Like, look at the number of remote operators of some of these pieces of equipment now. We didn't have that 5 years ago. We had all those same guys sitting playing video games in their basement, right? Now they have a productive job doing that. And so that's the kind of thing that people are like, well, we're just going to eliminate all the jobs with this stuff. No, we're going to create new ones. They're just stuff that you haven't seen before, we haven't done before. So it's being open to those transformative changes. So the short answer is yes, we see those changes coming already in our industry. We are embracing that. We're trying to apply the innovation. I have staff members working with AI every day. And how can we improve the way we're doing these different things and automating more tasks, and call it the man in the middle, type of approach with agentic agents. there's no question that is our future, and that we should be able to make things safer, more fun, less hours of work. Like, who wants to be on a roof in Phoenix at 120 degrees? Who wants to be standing in front of that piece of switch gear when we're doing a new switching test, right? I don't care if you're in the arc flash gear or not. Nobody wants to be there, man. So I think bringing these technologies into the data center space to create a safer environment, to move things along at the pace that we need to move them, the reality, and I keep reminding everyone, there's more workload in this space coming than we have people available to do it, period. So even if we were to do 2x more of it with, robotics and drones and all this other stuff, guess what? You're all still busy and employed.
Right.
That's how big the scale is that we need to do for the next 10 years.
Right.
So in terms of like the positive image, to the industry, I think I'd like everybody to keep their eyes on the prize, which is the enablement of this technology is raising the quality of life for everybody, right? AI is raising all ships. And so while we can all speculate, could have a really bad outcome or could have a really, live in the moment once in a while. And the moment right now is fantastic as it relates to what it's enabling. Now, are there a lot of bad things? Sure. Can it be misused and abused? Sure. But I think if we all collectively start making it a better thing, we'll get a better thing. If we collectively make it be bad, guess what? We're going to get that outcome too.
Yeah. Well, you and I are going to do everything we can. So that's not the outcome.
That's right.
I think that there are, just whether it's the Nancy Novaks of the world, my buddy Phil Lawson-Shanks over at Align, David Quirk of DLB Associates, there is the overwhelming majority of the community that I know that has been here for a minute. And what's attracting people, at least in our organization, to come and join, they want to be connected, not just to the economic opportunity, but over and over and over. The cynics of the world are going to dismiss this, but it is, I believe, 100% true. I want to be part of something bigger than I'm attracted to that culture, and we're attracted to them. And I think that as we have Joe Cava from Google, these other folks, or whoever their successors are going, these conversations will continue to come together, and there will be functions where we will get to standardization or whatever it is. But it is, right now we're in a season of disruption and change. And I just think that's the way it is right now. There's the opportunity in front of us. So
select standardization is probably the answer, right? Just, we only need to solve for some minimal portion of that problem, and we'll still have a great outcome for the market as a whole. And like you, I believe in the underlying technology, and it's the betterment that's going to come from it. Like every technology we've ever created, you can make both arguments all day long. That's the beauty of technology in the first place. But by and large, look at history. Technology has done more good than bad on a whole measured basis, no matter which metric you use. And so has increased intelligence. And now we're doing both. So I think good things are coming. We covered a lot. What have we not covered that we need to finish up with today? That's a good spot. We didn't talk, religion. We didn't talk politics. We didn't talk sports. Like, we left a lot of things out, man. We're going to have to do this again.
David, thanks for coming on the show today.
Thank you, David.
My great pleasure. Hey, if you like that, hit the like button. And if you loved it, hit the subscribe button. We'll see you next time. Have a good one.